Hello. In this video we're going to quickly go through and just comment about this code. Someone sent this to me and asked me why it outputs the value of 1. And really simply put, what this code does is it finds the smallest value in the two-dimensional array. So this line here, we've declared a two-dimensional array. We've set our value. We've declared an integer called v. And what's really nice here is we've set v to the first element, or element in index 0, 0, because it's a two-dimensional array. This is a really good practice. If you're looking for the smallest or the largest value in some sort of data structure, initialize that smallest or largest value to the first element. It's going to save a lot of kind of logic problems later on. One thing I would suggest here, make your variable names descriptive. So if you're finding the smallest element in an array, you're going to call it minimum. You're going to call it minimum. Okay. So this line here, the value v is the value at the start of the loop, and then here we print out min, so that's the very first element. So essentially it's just saying this is currently the smallest value. Okay, I'm just going to get rid of this line now. This is what's happening in the values v. So this is an interesting thing here. Note, this line here will print out a reference to where the array is stored. Arrays are reference variable types, meaning that if you try and print out just the variable name, it's going to give you the memory address of where that information is stored. So if I come down to my output screen down here and I look, that's the memory address. It's going to change each time you run the program, but just be aware of that, is that when you actually deal with the name of a reference variable, you're actually accessing the memory reference, not the data. So here is our first for each loop. When I have multiple loops, sometimes I like to comment them. This is loop 1, there's end of loop 1. This is my second one, loop 2. So what I'm essentially doing with a nested for each loop is I'm taking the first row of the array, the two-dimensional array, and then I'm kind of running through it with the second one. So this will grab the first row of the array, and then this will go through each element in that row, and then I go to the next one. So then it prints out the current minimum value. So let's just take this, let's change the language here. Current min is, and then we'll say current element is, and then we have our if statement. We say if the minimum is larger than the current element, well then the minimum becomes the current element, and then we say the new minimum is, and if I go outside my loop at the end, I can go something like put line smallest element in the data structure is min. So if I run this, I get the same thing. So notice what happens here, and actually let's do this to make this a little clearer as well. I'm going to do a system.out. I'm going to just do a blank line here. There we go, and I'm just going to do a blank line down here. Make it a little easier if we were looking at our console. So if we scroll up and we look at this, so when we start the loop, it's going to say the current minimum is 3, the current element is 3. So essentially I'm setting the minimum to the very first element, and then I enter my, oh sorry, pardon me. Yeah, sorry, pardon me. So I print out, let's start this again. This is what's happening in values, which is located at this memory reference. There it is. And then I enter my first for each loop, and I take the first row, I enter my second for each loop. And I see the current min is 3, and the current element is 3. So min is not greater than element, so what it's going to do is it's going to skip this next one. The current min is going to come to the bottom of the loop, come back to the top. Compare 3 and 4. Compare 3, the min against 4, doesn't swap. Compare 3 against 5, doesn't swap. compares 3 against 1, and then because 1 is smaller, it swaps them out. And then it goes to the next row. It's going to compare 1 to 33, doesn't swap. It's going to compare 1 to 6, doesn't swap. It's going to compare 1 to 1. It's not going to swap them because it only swaps them if min is greater than elements. It's the same. And then it compares min, which is 1 against 2. And then when we exit our structure, the smallest element of that structure is 1. Watch, if I make this negative 33 and I run this again, now it finds negative 33. So this code is finding the smallest element in a two-dimensional array. Just a little side note, you could do this as well using for loops, and let's just do that. So for int, I always like using R and C because I think of it, I connect it to math in rows and columns. So row is 0, R is less than values.length, R++. For int C is equal to 0, C is less than values at on row R, the length essentially of that specific row, C++, if, and then I say values at R row C. Again, I always use R and C because it kind of sets me up when I learn about matrices and mathematics. If values at R or C is smaller than min, we're going to say min is equal to values at R C. And let's come up here and let's comment out. Let's comment out. There. So I still have the same array, and in fact, let's take this. Let's put this down here. So there's my array. Then I make a variable called min, and then I have a for loop. This starts at the first row, and then I go right across the row, and I do that condition. If values at RC is less than min, I replace min. If I run this, there's my minimum value. If I make this, put negative 200 here, or 2002, sure, there we go. And there we go. Notice I could put braces in this case, and some people like to do this. And often when I'm teaching students first how to program, I always put my braces in, but if you have one line of code associated with a loop or a logic structure, or conditional structure, pardon me, you don't need the braces in there. So you don't need braces in this case. I hope this helped. Have a wonderful day.